Hello everybody, welcome to Rocket Lasso Live episode 9. How is everyone doing today? I hope you're doing well. Not too much to cover today. Start getting those questions together. If you are on YouTube, then you can type out a question. Otherwise, if you want to post a link, head on over to Twitch instead. There should be a link in the description if you wanted to do so, but I like typed out questions. If it is a link to a studio or artist who created something, I need to see the name so that I can give appropriate credit. Otherwise, ask a more genericized question. And I'm not sure the way it works on Twitch. And the only other thing to cover is, let me switch over here. What's the best way of pulling this up? But anyway, I've got a new tutorial uploaded as of Monday. And it's a highlight from the live stream a couple weeks ago where we did all the stuff with fields. I trimmed it down a little bit, but we cover a whole bunch of really nice details, and the overall video is only 9 minutes long. So totally worth checking out to get a whole bunch of advanced field functionality here. I was just really happy with that as a clip. So I'll put a link to that in the chat if you haven't gotten a chance to check it out. That is one of the very first ever highlights of a Twitch stream. Skylar's first time chatting, saying local fog using Redshift, as in fog in just one area. That is a good question. I don't feel like I'm super qualified to answer it, but let's open it up. Actually, we'll intentionally do this. It's a little bit risky because we were talking about how my video cards get upset about live streaming while doing some Redshift stuff, and I don't know if it's Redshift stability or possibly just my computer. We'll see what we can do. And I do have Redshift set up as a default, so watch me fumble my way through doing a little bit of Redshift here because it's an area that I haven't done a lot with. So in order to see, actually, here's a really simple way of seeing seeing if the fog is actually kind of working, is I'll make a multi-instance and make a whole bunch of clones out into space. So if we set this to, per step, and we'll do, let's do 11 by 11 by 11. So we should get this giant grid of these going way off in space, and it should be really easy to kind of see the fall off happen as fog would be happening. So as I mentioned, I kind of expect, why did my menu change here? I want that to be a list. Yeah. Not the raw recording, but the scene files. As always, these scene files will be available to people on Patreon. Redshift fog test. And that's just in case I do crash. Okay, having done all that, I set my default scene to already be in Redshift mode. But it's all kind of the defaults. So let's get some very basic Redshift fog going. And let me see if I can even remember, because you got your basic lights and you can get those to give you fog, but that requires a Redshift environment. See, it did that thing again where it's automatically making things a child. It's very strange. So we've got the environment, and there's emission, and what's that going to look like out of the box? Does the Redshift environment do something immediately? I don't even know that. So let's go to render and render to render view, I believe. That opens up, and let's hope. I'm going to pause that. Is there any way to stop that from turning on immediately to have the render already on? Because I always go to the IPR, which is what I want to be on. Okay, so we are now seeing this. Let me know if the stream starts dropping or anything like that, but now that's turned on. Let's see if we can get a little bit of fog going. So I'll turn on a decently extreme color, and here's some fog, which is what I think we want. So let's set that to, I'm just setting things to very bright colors, so we'll be able to obviously see it. Because I don't know how to do this, you'll see a little bit of my process of trying to intelligently get something working quickly, because I don't know if pure white will show or if pure black will show. So instead I'm going kind of to a halfway point. I'm making a very distinct color, so that will jump out at me. Now currently there's no height, and I wonder if no height means it goes everywhere, but I'll attempt to drag that up a bit. And I'm also wondering if we need, okay, so let me drag fog height down, and by adding in some attenuation, suddenly fog is appearing. So now we have fog everywhere, and that seems to apply thickness. It's a little bit strange to me that attenuation is applying the green color, but is it the opposite? So let me change this to more of a blue color. No, looks like attenuation is affecting the emission. So I'm not sure what this tint actually means, but I'm just tinkering. And so yeah, we're definitely seeing that. Now somebody in the chat is mentioning that we'd need a light with volume contribution to see it, but we are seeing some fog here, like clearly. If I start cranking this up, yeah, you'll see some very distinct fog. If we get near some of these, we should see the close ones pretty clearly, and then they're going to fade out. So a nice overall fog. Now, the question is more about getting it to a specific area. Now, let's, as a basic thing, let's try creating a light. I'm going to start out with a spotlight, which I think is going to be the least interesting of them, but I think it's going to be, mechanically speaking, the most visually obvious one. So let's make sure that this beam would indeed be casting out pretty well. I'm going to extend that out further, and immediately we can see that's blasting out light. Now, this by default, yeah, you can see it's contributing to the volume overall. And now that we actually have a light contributing to the volume, we can see that the general light is actually what the color is. So we should be able to put that back to white now that we see it does show up, and we can indeed see that that send out a beam of light. If we get rid of all of the attenuation, then now all we have is that beam of light. I will create a dim dome light, and it doesn't need to be very bright, so I'll set like 0.1. I just want to, even 0.1. Oh, this might be contributing to the fog. So I'm going to say don't contribute to the volume. All I want to do is get a little bit of light on the overall scene. And honestly, it's probably a good idea to get an HDR in there just to get, this even lighting isn't helping anything. And let's turn off background and search for HDR. And actually, let's search for .HDR so it actually shows the images. And just grab one I've grabbed before, drop it in. So there we go. We actually are seeing a little bit of something filling out the scene, but we can see that our beam is very strong. Now we've got scattering. Is that, yeah, this is going to be a giant multiplier and everything. So a little bit goes a very long way. You can see how much that's blowing out. Of course, we can pull back or forward on the different volume, or, the different lights, volume multipliers. Now, having said that, there's a lot of ways in like vanilla cinema, in like standard and physical renderer, where we could do things like turn off the intensity, so it's like it wouldn't be casting any light. But because Redshift is a lot more realistic, I guess, like the things are coupled together. So realistically, if there was no intensity, there'd be no light. And I don't know, well, actually here we can say, hey, don't contribute to the diffuse, don't contribute to the reflection. And I'm not sure which other ones, but I'm going to turn off almost everything. We got this global illumination. So now maybe we do have a light that is just a visible fog, but it doesn't actually cast light on anything. So let me pull this dome light back even dimmer, 0.01. So just barely a little bit of light so we can see where things are. And if I were to tell this spotlight to also have no volume, then you see it's not doing anything. Meanwhile, if we put the diffuse up, it's actually casting that light. So we are able to pull those sliders back, which is kind of cool. Now, like I said, the spotlight was going to be the most visually obvious one. So let's see if this beam of light carries through to some of these other ones. Like if we do an area light, then yeah, we're getting this nice giant beam flying out. And it is just having its own natural fall off. So, I mean, it does look cool, and we're going to get this fall off from it. But it is going to be, I'm assuming, we do have these different fall off types. I doubt those will apply to the fog. But let's see if we can, oh, no, it does seem to change. Okay, that actually is important, where it does seem like this does follow through. So if we say quadratic, that's going to be falling off in a, quadratic is going to be the realistic kind of mathematical way that light really works. But doing something like linear will give you a lot more direct control. Before we get there, though, I want to see if a point light also will give us fog. It does not seem to. Let me make sure that we're not inside a sphere. And no, we're not. And yeah, moving this one around, I'm just not seeing any fog. So I don't think a point light gives us anything. Going back to the area, well, let's click on a dome light. We know that one sort of did, but I don't think there's any kind of radius on this. So again, back to an area light. And let's see, because that's a rectangle shape, but let's see if we can do a spherical shape. Okay, good. The spherical shape is now essentially what I wanted from the point light. Can we put the radius down to 0? No, it doesn't like being at 0. But in theory, you could probably go pretty small. And presumably, we'd have to like start compensating. Okay, so now you can see that we get this nice little glow. So essentially what we're doing here is making something kind of similar to what the cinema ones do. So by having this very small point of light, we can start cranking up the power and we're getting a fall off from there. Now switching this from the realistic quadratic, I can change it over to linear. And you see it's super blowing out really far, but you see we have a start and a stop. So that might give us a like perfect radius. So if I set that from 0 to 50, you can now see I'm getting this perfect linear fall off from 0 to 50. The brightness here is probably going to be a major variable. If I start pulling back on that, let's see. I wonder if well, okay, going to 1, you can see a little bit of glow and it fades out. Let's go up to 10 and yeah, it becomes a lot more solid. So now you can see that we have, at this point, we have something very similar to regular cinema, that we can create these individual fall-offs, have it not contribute to anything else, and just create a nice bit of fog. So hopefully, yeah, just saying T for scale, I could scale this up. Of course, I think that is scaling up the intensity, or at least the intensity is a multiplier. There might be a way of delinking between those. So that scale doesn't modify the intensity, but I'm not sure what setting that would be if there is one. So that's like some very basic, like, oh, that's kind of like Cinema 4D. Actually, I'm going to check the chat and see if anybody's throwing out additional details, because I have a different direction I want to go, but I'm really quite fuzzy on it. I'm probably going to do it wrong because I haven't done it in a while. Dean, I see that you posted a different question. I'll jump onto that a little bit later. And then Dim is mentioning that the problems I was having with the GPU stuff, that it was eating up all the GPU, so there's nothing left for the stream, and that's agreed. And a couple weeks ago, we did go and change the amount that Redshift was eating, so I think it's only using up like 60% now instead of its previous like 90%. So hopefully that's better. Dim is also mentioning that we can click Normalize Light, and where is, oh, here's Normalize Intensity. So presumably that now is decoupling the scale. So if I put this at 10 and I scale this up and down, yeah, you see the brightness isn't changing. So yeah, I figured there'd be a setting like that. And Dim, thanks for mentioning that. And that's doing a very nice controllable fall off. And we can do a bunch of different shapes, especially just from the area light and the spotlight, where we can be setting this to a disc shape. Actually, I guess the disc is still going to, the disc isn't going to look too different, I wouldn't think. Does it, where is it? Is it kind of flat facing forward? Yeah, it's kind of doing a dome, so that's kind of nice. Yeah, it's sort of a dome, but that's going to be very similar to the overall. Oh, I guess that does make sense. And then we can also potentially feed it through a mesh. But I think that it's just going to be where the surface is casting, so I'd be a little dubious about the specifics there. But yeah, thanks for the hint about normalizing it. Now, when it comes to actually placing fog in a very specific spot, I would think we'd want to use a volume. I forget, maybe I'm even using the term wrong, but we'd want to use a volume and do it via a Redshift volume material. I'm a little bit fuzzy on there. Oops, Zach's here, so maybe he can point out when I start doing things wrong. But what I would like to do, let's brighten up the overall scene just a bit and turn off this glowing light. In fact, why don't I save that back to sphere, and we'll put a, let me hit undo a few times. Undo, undo, undo. There we go. I'll save that as that file. And now let's go to 1B, and we'll do a completely different concept here. So instead of that spotlight, what I'd like to do is brighten everything up a little bit. And try and make a volume and apply a material. But I know that the settings are very particular, so I might need a little bit of help there. Now, a immediate thought is, well, we can create our own cloud. So this can kind of double as like, oh, let's make a cloud tutorial. So our scaling is pretty arbitrary right now overall. So just to throw it out there, if I were to make a figure, you can see that that's the size of a person. So let's just say we're making a foggy cloud And this is approximately the size I want to make it. So here's my thought. I'm going to Control X that, save this as our secondary scene file, open up a new file, pause Redshift because we don't need that, and paste it in. And now this is our guide for like, okay, this is approximately where I want things to go. Now, a lot of different things we could do here, but keeping it as basic as possible. I'm thinking let's just clone some spheres, where I'll make a cloner and let's clone these. I'll do it linearly and no offset, and let's say there's 100 of them. So there should be 100 spheres stacked up on top of each other. And then via a random, we can start spreading them out. So I'll say, okay, I want to go out about that far and about that far and about this far. You can see I'm kind of making an overall cluster. And let me think, what other things should I do? Let's do a little bit of a push apart. It's an appropriate use of that, but maybe I don't want to go that far apart. So we can, you know, just have them spread out a little bit. And I'm trying to think of, I kind of want it a little bit more clustered near the center, but honestly, we shouldn't overthink it too much. I might even make a second cloner. And here's a trick if you didn't know. I can say this random effector is affecting. I'm going to overweigh it. So even though it's the exact same random effector, I can like double up the power from it. But actually, I'm not going to do that because this one, it's funny what the push apart does. This one, I will just push a second random on there because I don't want there to be as much verticalness. So I'll just spread this out like that. I'm just trying to get a little bit more definition in the cloud, where like we can puff up a little bit in the middle and have these kind of fade out a little bit more towards the edge. Nothing crazy. Okay, now I believe we should, let's just create a connect object and drop them both into this connect. I don't care about the welding, so I'll turn that off. And now that all gets fed into a volume builder. So now we've got a volume, and we are going to be, I think maybe we can do it with signed distance. I'm trying to remember how we export, because I haven't done it in a while. But let's do a couple other things. These are just kind of spheres right now. So let's create a smooth, and you see immediately those will start blobbing together. We can add additional iterations like that. Maybe I can spread, oh, that dang random, or everything's being made a child. I'll spread them out a little bit wider. Put a couple of different random seeds. All right, not the most amazing cloud, but you can see we kind of got a bit of a blobby cloud. Now, I'm trying to just do this the best I can from memory. Do we need, what do I need to do? If we make this editable right now, it's going to create this volume builder. And you can see that's got a file path for the volume builder, and we can save it. So I think that's mostly what I want to do. I made, if you didn't know that, you can make a volume builder directly editable. So I guess we just can click save here and save it into the scene file. I'll just leave it here. So we'll just call it 1B fog. I'll say cloud, why not? Okay, so that is, in theory, that's saved as a VDB, as a cloud. But I will hit undo a few times. And what happens if we change this to fog? So then you get fog, and I feel like something, but now the smooth doesn't work. But then there's a fog smooth, and now you can see how that's fading out, and we can put a couple of those. So this is a different type of setup. What else do we have? Multiply, fog, add range, remap. So yeah, a bunch of different things going there. I will again make that editable, and you'll see again we get a VDB, but even here it looks very different. I think even the icon looks different. So I'll save that one as well. So I'll just name that as fog. I'll leave it as B, but I'll put underscore fog. Save. Okay, so now I've made two different VDBs, and those are things that we can reference like completely independently. So, and I guess I made this not editable anymore, so I'll save it as well. C, and this will be cloud maker. Okay, back into our original file, and we can still stay in this world of spheres. I would like to bring in the VDB. Let me see. I'm trying to remember from memory. I've done this before, but not in a long time. Do we just bring in the raw VDB? And if so, I don't remember how to make a VDB. Do we just import? Maybe. Oh, Redshift volume. Okay, Redshift volume. That it wants to load in something. So let's go to our scene files, and I'm going to try dragging the fog, the second one we made, just because I feel like there's slightly better odds of that working. So now you can see it made a big giant box, which is, I don't know if it's overscaled or if it's the correct size. We did end up making that cloud a little bit bigger. I didn't reference the cube again. So I don't necessarily expect to see this immediately. There's a good chance that we can't see this if we don't have the Redshift environment. So keep in mind that that might be a necessary component. Oh, there's a preview. So let's say points. There we go. And I can say how many points we'd like to see. So yeah, that actually, it's doing a pretty good preview for us. Okay. Now, most of what we need to do, I think, is going to be under the volume. So let's drop that on here and move inside the material, Redshift volume. So this is all about the channels, where we have these different channels and these different presets. The Redshift volume builder probably. And yeah, it's once we get to this that I always have a little bit of trouble getting it to show anything. So let's pull back over our Redshift render view. We'll scale this up a bit. And okay, you will see that something is rendering. We've got this black cloud in here and it is blocking out our view. So I did feed in the volume builder channel into this. So we've got our scatter coefficient. I'm going to try making that very small, 0.01. That seems to have made it more solid, but it's hard to tell. Let me put back to 1. That feels like it's a little more transparent. I'm not sure. I'm going to go, yeah. Oh, okay, so I just put another 10. If you watch my stuff, you know that if I don't know what numbers to put, I start doing multiples of 10. So by increasing that number 10 times more, I'm starting to actually see something. So that is now becoming at least transmissive. We're now seeing some light through it. And if I go another 10, you're going to see it's become quite bright. I feel like 11 was a pretty good number there. Now we've got our absorption coefficient. And right now it should be universally applying because we're not feeding a channel through it. In fact, we could try deleting out our volume builder. And yeah, it was good that we put the volume builder because without that, nothing came through. So let's bring that back again. Now I will try not feeding anything in this channel, and let's try going 1/10 the amount. Now this is having an effect in spite of not having something in the channel. So let me try going 10 times higher than the original. That went and made it really dark. So being back at 1, I like being able to see these grays. What I really want, that's emission, which that's going to be, just how much it glows by itself, and which essentially we don't want any of. But what I really want is I want to try and make this transparent a little bit. And I'm trying to think of what, we can change the tint. That's probably just going to be an overall multiplier. So yeah, the entire thing gets colorized, and that's fine. We can leave that colorized. Absorption. I mean, this could be, maybe both need to be modified. Maybe this needs to be, weren't we saying that? Well, which one? Yeah, if I make it smaller, it seemed to be thicker. So if we go way bigger, does that make it more transparent? It's making it brighter, but now I'm going to try changing the absorption and see if there's a correlation there. 0.1. No, that doesn't seem to be making it too much more transparent, but let me try making way smaller numbers. When it comes to something like really thick like this, you might end up needing like really small numbers. Okay. Oh, well, some combination I just did there. I just went very small on our scatter coefficient, and now you can see we are able to see through it. How much of that was to do with the absorption? Apparently, we did need a really small absorption, and now we've got a really small scatter coefficient. Put this back to white, and now, hopefully, we should have a fog that is existing only in a very specific spot that we wanted it to, and we should be able to control the thickness of it. So yeah, we can see this character now is in the fog and it's fading out from there. There's gonna be a lot of very specific settings. I'm very pleased that we got here as quickly as we did. I didn't go down too many bad detours. I don't know enough to be like, oh, absorption, that's the one that you should have be at this small number. Like, I'm not sure if we want this to be more transparent, do I make that number smaller? Because that didn't seem to make it more, and that's absorption. So I think that would be the brightness overall. The scatter coefficient, that seems to be the one we need to go really thin. So yeah, as I make this number thinner, you can barely see a little hint of fog through all of it. Light should still be affecting it. And we can colorize it. I think we want to make sure we leave black where black is, but we can do any other colors as we go higher. So this could be like a really bright red. So now it's going to go from transparent and black through red into the center where it's the most thick, which would then be white. But you know, that can be whatever color. So that, yeah, it's going to transition into yellow. So we have very clear control over that as far as what the colors are, and you can see it fading out from one side to the other. In theory, we could feed in different channels, but I'm not sure of inside of a generic, like in our setup, like making a volume editable. I'm not sure how to get multiple channels. If you're using something like X particles, I know you can like extract all sorts of different data from there. In fact, even in these presets, you can see that there's like getting stuff from turbulence and getting stuff from fume. So a lot of options, but we're just using the raw volume builder. Let me reset that to default. So we've got our cloud of fog. Oh yeah, I wanted to see if turning off the Redshift environment turns that off. And no, it doesn't. So apparently that's unrelated. Turning that back on again, though, we could start cranking up our attenuation and get the overall fog back in. And you can see that these two will play nicely with each other. We can have this white overall fog, which is causing it to fade out. But in this particular spot, have that be a more solid fog so we can combine both. Let's make that very solid via, presumably, oh yeah, it's via the material. Specifically this volume, so you have to go a little deep. If I want this to be more solid, I think we just drop or increase that up to 0.1, and yeah, that makes it significantly more solid. The brightness is going to be via the absorption or the emission if you wanted it to be. I wonder if there's if I put that to 0, is it there, but just kind of ambient? So let me increase that more. Increase that more. No, it seems to have completely disappeared. So it looks like a little bit of absorption might be necessary. If we put a lot of absorption, then now it becomes solid. So now you can see I'm starting to get this nice black, smoky look from it because it's absorbing the light very quickly. So it could absorb the light very quickly and yet be very thin. So 0.01 is going to be 1/10, as if there's like only a tenth of, I would have thought that would work, only a tenth of the volume. But actually that seems really, really solid as I go to smaller numbers. Yeah, that doesn't seem to be changing much. So, okay, I was wrong there. And I don't think going higher is going to change that. Oh, well, now it's starting to get, it's starting to show some of the form of it. So, okay, actually, I guess that does make sense. Going back to 0.1, because I just like to look at that. But I guess the absorption coefficient, I guess a smaller number there would make it more transparent. Yeah. 0.01. Yeah, so we're starting to lose some of that, the volume. So I don't know, there might be a little bit of push and pull there. We might be able to change the color of it. But yeah, that's essentially we've now pushed the limits of my knowledge on this, and something I haven't done since I made the Ricochet commercial, which is going back a while now. Anyway, let's double check the chat. Ulfsub, thank you for subscribing with Prime. Everybody, if you have a refreshed free Prime sub, then that'd be great if you get a chance to use it. Ginger root, volume, presets. there are presets to select on the volume builder. There probably aren't because I'm in this new material. You can see that this is the, not the node editor. No, it's not the classic one, it's the cinema one. So there are no presets, but there sounds like if you're using the old style, then there would be. I don't even know. I think I can't even remember how to set it to the old one. I think I have to go into preferences and turn off this to get to the old style. But I'm trying to stay in the new whenever possible. Yeah, like I said, I'm not an expert on this, so I was going to say, are there any follow-up questions to get that going? But I fear I wouldn't be able to really answer them. What's cool is, like, even here with me having this kind of faint fog, you can, this is getting a little bit dangerous, but let's save that. And you can even do things like clone this or make more than one. So the, if I make a cloner and we don't, yeah, the 3x3 is fine. So if I drop that in here, we're going to get multiple copies of it, put a little more breathing room between them. But you can see I've got 3x3 of these. Bring back in our renderer. And now you can see that, yeah, we have like not six, 9 different fogs going on here as they travel around. And because it's a cloner, I do believe it does work where you can do things like create a random, and here I could give it scale, uniform, absolute. Maybe we wouldn't want to do absolute, but I can like start increasing their scale. And now some will get smaller and some will get bigger. And then on top of that, if we did some movement and we can do some rotation, let's like spin that spin around a whole bunch. That's not a great looking cloud, but even just if you have like even just one generic looking cloud, by scaling it and stretching it and rotating it and layering them on top of each other, you could start making more complex layouts. So you actually don't need too many of those before you can actually start getting something very art directable, where you can see we've got all these clouds layered up on top of each other. And yeah, pretty powerful once you start getting into that. And you should be able to make like realistic looking clouds and fog and smoke, potentially even fire and emissive, and make things glow via, I think even light could be coming from it. The what's the main setting for, I was wondering if this had an individual setting for the rays or the samples it would get. Maybe that's in the material. Samples, basic. No, I don't see samples here, so maybe it's a global setting. Going into our render settings, I would presume that there's going to be a global transparency, refractions, system. Somewhere there's got to be a volume setting. I'm not seeing it, but I'm here. I'm sure it's here somewhere. Yep, I'm totally missing it, but I guarantee there's got to be a setting there. Because like I say, even here, you can see it looks a little bit grainy. I'm not sure the best thing for it. Somebody's saying turn off automatic sampling, but that doesn't... oh, automatic is making so that they're all hidden. Okay, thank you. So now I've turned that off. Now you can see that we get a volume, so I can turn that on and start cranking up the samples to be higher or lower. So double that, but let's double and double and double. Well, let's go up, just jump up to a 1024, and of course this is not set to bucket rendering, so we could turn that on. That's still significantly grainy there. I wonder if the volume itself didn't have enough resolution, because at this point I feel like that's pretty high setting. If somebody has an obvious answer there, let me know. But anyway, thank you, MJ, for that. Dean, yeah, I don't know if a cloned volume would render faster than multiple ones. I wonder, I highly doubt, I'm going to hit save just in case. I highly doubt we can turn on multi-instance, but I'm going to turn it on. Yeah, multi-instance I wouldn't think would work on a volume, so only the original, or only one was being generated. But yeah, I don't know if it's faster or not. Anyway, I think that wraps this up. It worked better than I thought it would. We were able to get multiple different types of fog, depending on your situation, inside of Redshift. So I will take it. Open up a new file. Let's see if there is more questions. I'm going to jump into YouTube first, see if they had anything pop up. Dynamic cable rig and scene nodes. I mean, you'd have to be more specific about dynamic cable rig, because that could mean a lot of things. That could mean like power lines sagging. It could mean bundled up wires traveling along a wall. Like I'm not entirely sure what you mean. And could you combine? Can you combine the new cloth sim with fields? And right now, not really, because even the field force isn't working with it yet, which is like the main force. So yeah, field force doesn't work, and field force would be one of the big things that would work with a field force. And to the best of my knowledge, there were no places. Yeah, there's no places to feed a field in here, with actually, I guess, one giant exception. And that is when you twirl all these down, you can see that we get places to put a vertex map. So let's do a very quick example, because why not? Let's add a decent number of subdivisions, make the floor into a collider, and text is boring, or a sphere is boring, so let's make a text object. We'll do a letter R, get a beefy font going, a little more depth, feed that into a volume builder, volume mesher. That's already doing a pretty nice job overall. Feed that into the remesh NB. We can now see we get a pretty nice clean mesh there. I'd like this to have more resolution though. Crank that up. There we go. That's looking a little bit nicer. Remesh, drop that down to 25%, please, with 0 adaptiveness. So there we go. Nice low poly, very even-sized polygon count overall on our letter R. And let's make that a different color just to have it pop out a little bit. Okay. Now, if we're going to do a vertex map, we do need to make it editable. Let's save it. Vertex map / fields with cloth. Okay, like I said, we need to make it editable. I could, I'll make a duplicate of it for now, turn that off, make this editable, add a simulation cloth tag to it, and everything should be fine. We should be able to hit play. Oop, I hit stop immediately because I should Control D for my own computer, go to simulation CPU, and hit play, and now we should see that fall and be surprisingly rigid. Doesn't need to fall that far. Okay, now, because that's been made editable, let us feed in a vertex map. So point mode, select, set vertex weight, doesn't matter what it is, because now we have a vertex map. Said vertex map will get fields applied, and there we go. Now we can be applying fields however we like. So I believe it is, let's actually prove this concept. If I shrink this down, you can see that we've got full strength up on the top and low strength on the bottom. I'll pull this out, and I'd like to move the entire object upward. So at the beginning, refresh please. Okay, you see that the entire thing is yellow, and sorry for the colors kind of hiding each other. What I want to see is, does this turn red as it falls through? And you see how it didn't? So this is not referencing the updated points. It's always referencing the original location. Keep that in mind. It says if it didn't move at all is what's being seen. And to prove that, we should be able to take this linear field. And if I start pulling it up, you can see how it started fading in, but it's referencing the original object. So that's a big difference where, depending on the circumstance, I could limit some things that we could do, but as long as we know what it is, it does give us some place to control it. So anyway, that's now a field through that. So let's go and turn that off and create a new spherical field. Perfect. Pretty much wanted it exactly there. You can see I've got a little bit of a glow on the corner there. And in the vertex map, I'll say I want it to grow. So we'll create a freeze and set that to add normal. And grow. The radius is probably too small. I'll hit clear and then hit play. And temporarily, I'll turn off the... Actually, we're not doing anything with cloth yet anyway, so I'll just delete the cloth tag. So back in the vertex map, you can see if I play, that is growing through the model. 10 is not quite enough to get all the way through. So I'll jump that up to 20. And put the effect strength way down at 10%. So it's going to grow slowly but more smoothly through the entire thing. If we wanted to get fancy, we could change the remapping, or I'm sorry, we can twirl down the freeze and you'll see a radius. And we can feed that something more complex like a random field. And let's leave the random field out for a moment so we can see the pattern. So you can see that if I increase the scale, we can see the noise pattern through it. I'll give it a bit of animation speed, so it's slowly changing over time. We're going to need more frames. And if I feed that into the radius, that is now behaving as a multiplier on the overall radius. So you can see that hopefully this is going to grow in an irregular pattern. So yeah, you can see how this is missing certain spots and growing because it's multiplying the value. Because I animated it slowly over time, it should be able to fill in everything. You see it did fade that out, and certain things will erase. Right here, it's just coincidentally missing until it finally got there. So keep in mind that that is a thing. Anyway, now that that is happening, and we see how this growth is slowly getting stronger, let us add in and hit save. Add the cloth tag back in again, and I'm thinking let's do bendiness. I'm gonna make it. We might need to reverse this, but I'm going to make it very bendy. I'm going to set to 50. And right now, the vertex map has nothing to do with it. So you can see right now when it falls, it was like, okay, it's very bendy, and the whole thing collapsed down very small. If we put the bendy down to 0, then you see it's going to spring back up and kind of be the full form again. A lot of this has to do with our low poly count. But let me put that to here. Yeah, you can see it crushes pretty well. Pretty much exactly what I want it to do. So now under bendiness, I'll drag that vertex map. Now, this is actually based on the name of the vertex map. It's not dragging it in. I think that was done so that it can be compatible with scene nodes. But in any case, that's going to be slowly growing over time. And let's turn that on so we can kind of see it. So as this falls, you're going to see it's okay. It is the opposite of what I want. You can see that it started out really rigid, and now it's slowly growing, and suddenly it's way more bendy because it's a multiplier. It's way more bendy, and it started collapsing after the fact. I want the opposite. So the easiest way to do that is create a second vertex map. I'll name it vertex map 2. Inside this, I will drag in the original one and then invert the end result. The reason we did this in a second vertex map is if you do it all within the first one and you put it invert, it can confuse the freeze where it starts like flashing and going back and forth. So anyway, all we did was invert that back into the cloth, and let's switch it to vertex map 2. So now the entire thing essentially, well, we can click on it. The entire thing is yellow, meaning yes, full strength. So that means multiply 55 by 100%, which means it's all the way up at 55. I'm even going to crank it up to 100. Hitting play. Hopefully we'll see the entire thing collapses. But now as that growth is slowly happening, which hopefully it is. Whoop. That behaved a little strangely, actually. The way it's transferring from one map to the other might be a variable here. I'm going to say vertex map, when you're transferring over, don't transfer via nearest, transfer via the index. I want to see if that's any different. Oh, it is different. Okay. Well, I'm glad that worked right away, but Curious. But anyway, you can now see that we are using a field or multiple fields to say, okay, you're really squishy. And then the growth is now saying, yeah, but then you're becoming stiffer as it goes. And the entire thing is reforming into this shape. So, yeah, just by using vertex maps, it does make fields incredibly powerful. I mean, vertex maps went from, like, I don't know, when fields were added, vertex maps before that were like, you'd almost never use them. They didn't do anything for you. And now after fields were introduced, like, vertex maps are suddenly one of the most important things in cinema because it becomes one of these, like, universal translators. Now, this is not something to explore now, but I want to keep in mind in the future that when I did make the second vertex map set to nearest, it did seem to be seeing the deformed geometry. So it's as if the vertex map was calculating after the cloth was running, which I don't know if that's true. That opens up possibilities and could be a caveat which could trip us up in the future if we are not keeping it in mind. But for now, that seemed to work pretty well. But yeah, that works really nicely. So hopefully that answered your question. I want to jump back to Twitch, but there's a question. Flavio is asking, could you simulate a tire getting attracted to a rim? Like, yeah, like as if the tire was using cloth and the rim was a rigid body. And also Yi Ha Kim, you can't put a link on YouTube. So if you want to put a link, go and join the Rocket Lasso Twitch chat, and you can post a link in there because your link is not coming through. How would I make a tire get attracted to a rim? Honestly, that feels like one of those things that I would do in reverse, where, yeah, doing the absolute simplest possible. Because I want to tackle some more questions. It's a good question, but so we'll do that, and then I guess I'll just make a torus. Make that fatter. Change the torus orientation. Increase that significantly. Increase this a bit. Make it editable. We'll do like an old school tire. Select that loop. Select that loop. UI, invert, delete, select all, T for scale, and shrink that until it's pretty much exactly on it. And how many segments did I have? Let's try 32. Yep, 32. So those are kind of visually matching. And I don't want them quite intersecting. So let's just say that that is, that's our tire and that's the rim. How do we get one to be on the other? Well, like I said, this is one of those ones where I would probably do it in reverse. Do you have to do it in reverse? No, I don't think you'd have to be in reverse. I'm going to add a bullet rigid body, and then on the torus, or we'll just call it tire, a soft body. So that should work right out of the gate. We should be able to hit play. Oh, that should be a collider. Off. And automatic, make it darker. So now, if we apply, that should just sort of collapse on the wheel. And the basic idea being, if we had a floor, actually we can use a floor, but now we're in Redshift, so it's not there. So I guess I'll just make a plane. So that's a collider now, and I'm thinking let's just make some wind, some real simple force wind blowing towards the camera. Hit play. It's probably gonna be pretty mild, but you see a slight breeze pushing it forward. So we could have that like blow it away, and now it's gonna fall off the ground. We could put a fall off and whatnot, but now imagine that it's like, okay, well that goes, and it's like, okay, that's where your tire is, and you want it to go back onto the rim. Well, right now, keyframe wise, I could say turn off the wind, and then the tire suddenly keyframe up the follow position, follow rotation, like a whole bunch. So 5 is a lot, or 10 is kind of the limit, So we'll do 5 and 5. So now if I hit play, you're suddenly going to see the tire be like, oh, I want to get back to this particular spot. We need more frames. And I don't know how well it's going to... You see it's trying to get in that position. It's kind of rotate around. If we did give it maybe less friction, it's going to be free to slide. And you see it actually got in that spot a little bit better. And if at the same time we also keyframed in... And then, potentially we do want that to go up to like 11. And then I could say, and then we'd also keyframe up the stiffness. So it's going to start trying to return back to its original shape. We could probably get pretty dang close to it getting back to that original position if we did a full transition of all those different elements. But like I said, what I'd be inclined to do is do it in reverse. So if we, right now it's currently following, but we wouldn't want it to follow. And I don't know if we want any friction or anything, but the basic thought would be, like I said, I don't want to spend too long on here. But if we do have the wind and I hit play, you see it's going to kind of blow away. But I don't want it to, I guess I'll put a fall off on there. Why not? Linear field, Z plus, pinch it tighter, scoot it over here. So the wind should stop as soon as it gets there, or possibly backward. Nope, it is backward. Linear field, Z minus. Hit play. So now you see it's going to fall, and then suddenly the wind would be turned off. And the tire probably still has almost no friction. So I'll put the friction back up again. So it's going to fall, hit the ground, and stop almost immediately. So it's like, okay, that's working great. So it settles down really quickly on like frame 180. So we'll go frame 125 and stop there. Bake the dynamics. We could do this individual object. So I could say bake object. That's going to very quickly run through. It's now fully baked. I can just scrub through the timeline. And immediately you can see that I could just scrub here and then go whoop, and then it's going to jump into the final position like perfectly because that's where it has to go. Now, if you don't want to be reversing your frames, we should... I think dynamics can get remapped. Can dynamics get remapped? Maybe the overall? No. I'm trying to remember. Can you bake the dynamics and then apply a remap to it? Because there's not very many settings here. Yeah. Because the actual quick way I'm thinking is I would just throw this into Alembic. So super straightforward. Right click, bake as Alembic. I guess it needs to be saved. I didn't save the overall scene file, which I should have. Now right click and bake as Alembic, and it should know where to go. So the original tire is not really doing much, and now we've got this Alembic brought in, and it's currently using the the exact same animation. But now we can say, hey, don't use the animation. We can actually keyframe things. So at the time of 0, we'll be all the way up at frame 125. So that's where it's beginning. Control D, animation linear, very important. So I'm going to keyframe over that again. Back to the Alembic. Delete that keyframe. Hold down Control or Control Shift deleted the keyframe. Now I can re-keyframe. Go to the very end and say at the very end it should be at 100. A perfect linear transition in reverse. Hits play, and now you can see that that's going to be like whoop, and immediately puts itself perfectly back on it. The timeline could now get longer again, and now you see that it's just going to be perfectly static in this position. So yeah, I would, if I wanted the rim to be on there, and obviously we could get way crazier, like we could do effects where it's like it kind of inflated, or different parts of it kind of like got pulled at different times. We could do the different kind of growth stuff we were doing on the other one to make them jump. But this is what I would do. Like I've done this, it's like if you have a whole bunch of books on a bookshelf and they're supposed to magically go into position, it's going to be almost impossible to keyframe that. And it's going to be very difficult for simulations to allow them to perfectly slide in there because they're going to bump into each other. But if you have them perfectly float away forward and then do it in reverse, then they end up exactly where they are supposed to be. Yeah, so there's that's my take on getting a tire to float back onto the rim. I want to jump over to Twitch again. Let's see, we got a couple first-time chatters, which is fun. And I am inclined to answer a question for a first-time chatter. So thanks for coming and hanging out with us. So from Avoid, you were asking about a scanning effect from one of my episodes, and you'd love to know how to do it from one of my episodes. Oh, okay. It's not from, you mean the scanning effect. Actually, you messaged me on, you messaged me somewhere else asking about how I did this scanning effect using Ricochet. So, and I said to hit me up during the stream. So coincidentally, you're also a first-time chatter. So thanks for making it over here. So yeah, I've got this scanning effect. Let's see if I play through it in the video. Presumably, okay, I'm scrubbing through, but you can see how it's moving around and it's scanning, doing all that stuff. You can also see like these little glowy beams on the spots where it collided. So that's the question. All right. Well, a lot of stuff in, well, let's just start building some things. Now, in that particular scene file here, I was using a whole bunch of, what do you call it? The bridge, what is that? Why am I completely blanking on the name? Well, it's just, the app is just called Bridge. And unfortunately, there's a bit of a bug in the, or at least they haven't updated. Oh, there's a new version. It's Quixel Bridge, by the way, but there's a new version that's trying to, I'm going to say later. Let me see if I can sign in. I'm on the other screen. I'll pull it over in a second. Everything's being very slow. Epic is loading very slowly. Come on. Come on. Okay, finally. Sign in. I'd have to look up the password and everything. Well, anyway, I'm not gonna try and pull in the models. But anyway, you know, Quixel Bridge has all these really great elements, and inside my library, I was paying for it for a while, so I had a whole bunch of different elements that I could use there. I wonder how quickly. Let me see if I can actually find that scene file, because then we could kind of work from it. I wouldn't be able to share the scene file. That's the problem. All right. I want to be able to share it for people on Patreon, so we will not work from the old file. We'll do it from scratch. But anyway, when it comes to a lot of the stuff with Quixel, you end up making the setups. The setups end up looking actually very similar to this, where you bring in a nice piece of grass or a clump of rocks, but it's going to be hollow and there's kind of nothing underneath. Sometimes there's a full model, but oftentimes there's not. So then what you end up doing would be, and what I did in that scene was a lot of creating of an instance. So it's like, here's a copy of this, and I could scoot this over, and then T for scale, and then go to object mode. I could scale that larger and pull it over here and rotate it a little bit. And then I'll make another copy of that. And then you take it and scoot it over here and spin it around. And by taking these and starting to layer them up and kind of hiding the seams the best you can end up making like some very layered up and complex models from very few source objects. So like a couple of different hills, a couple of different setups, and you could get something pretty good. You know, and you see even here as I start getting it, where it's like, oh, we almost get like this little valley effect, and then you get like some rocks. So, you know, I'm gonna call this sphere a rock. So it's like, oh, here's a sphere. It's like, okay, well, we're seeing some seams really blatantly, like maybe right here. So it's like, okay, well, let's put a rock right there, and then again, that rock would probably be another Quixel model. So I'd make another instance of it, and then scoot this instance over here, T for scale, and scale it down. And as you would start, I can hold out, I can hold down Control as I drag this copy, because it's now an instance. I can keep on making more copies here. And you see how I'm hiding that seam underneath these boulders. And that's a concept with a lot of Quixel stuff. At some point when I've got that all set up, it'd be kind of fun to go through and, you know, properly do like a little Quixel type setup, because those are really fun in a making a video game level kind of way. Like, it's very kind of fun and zen. And even pushing that further, like something I would often do would be, we've got this model, but I could scale it. We go to coordinates and you can see how I've got this overall scale here, but I could say, you know what, let me scale this perfectly negative on X. So I've mirrored it on one dimension, and it actually makes it really difficult to tell that you're repeating the object, because it starts feeling so dramatically different. And once you do this type of thing, you start getting like really nice sight lines. Like these have these sharp edges, so it's not working amazing. But you can imagine even just taking this original model, I will reset its position. But if we were to take that and say, okay, let's pull that way back in the distance, T for scale, and start scaling it way up, and then move it down, T for scale, scale it taller. It's like, oh, well, now that exact same model is now representing a model or a mountain way in the distance. And it's like, oh, well, let's make another one. R for rotate, spin that. I could even tilt it forward a little bit. Now that looks like a completely different mountain. One more, and this one Could go even further back, further down, T for scale, and then that one starts feeling even bigger, and you could layer, layer, layer. So anyway, that's just a basic way that a lot of the stuff ends up going with modeling something or layering something up in something like the models from Quixel, which are, it's quite fun, quite satisfying, and I highly recommend it. And it's really where you can like kind of really carefully pick your camera angles. I'm trying to actually angle this so we can actually get something that sort of works from a particular camera angle. So yeah, now I've kind of hid those seams. So if we pick our angle correctly, it's like, okay, we've got like suddenly a bunch of different layered up and detailed things, all from literally, and yeah, this could be a giant wall that we could scale up and gets really close here. Make another one, move this really far away, pull it down. And you just start getting those things at distance. And as soon as you get like a little bit of fog, like that would be fading way out in the background. So, all the same object repeated again and again, and we get this entire scene. So now that we've kind of got our scene, and it would be really smart in this case to create a camera. And this would be a good instance maybe to make a recall tag. Recall is a plugin that I designed. So if I had a recall tag, I can double click. And now it's going to remember that. So if I click on this camera and I go and I move over here, it's like, oh, I need to manipulate and need to change. You can see how huge these are. But now I can just double click on the recall tag and I jump right back to where I used to be. So it's a very, that's one of the best use cases for, or the most common reach for instances on a recall tag. But anyway, we've now got all these models, and it's not that many. In general, we got a lot of geometry, but these instances can actually calculate pretty quick. So now we could make something like Ricochet. So under extensions, we've got Rocket Ricochet. So I can create that, and we need to be colliding with all the geometry, essentially. I want it to collide with everything in the scene. Now, we could drag all the individual objects into the scene. I could also fake it via, I'm trying to remember how the way I specifically did it, but an easy thing I could do right now would be just create a connect object. So if I create a connect object and throw all the stuff into the connect and don't weld, then this now represents all of the meshes. So I could, in the future, I could be like, oh, you know what? There's, I have to turn that off, but I can click on that sphere. Actually, not that one. Let's say this one. And I can E for move, hold down control, and make a duplicate. And now I've successfully made a copy of that sphere, and it's a child of the connect, which means it just automatically updates, which is a nice big advantage. But anyway, now that everything's in this connect, and we just rename that all, we've got our Ricochet. So anybody who's not familiar, Ricochet is a laser. You can see here that I've got this laser shooting. And if I say, hey, laser, I'm going to remote in. So I'm going to say, look at objects. The object will be all. And then, again, the reason to do the connect is we could make more objects, and we just have to remember to drag each one of them in manually, and now I don't have to. But anyway, we're now seeing all this geometry. We've got this laser shooting out, but now that we are referencing all the geometry, I could rotate this and spin, and you'll see that when I hit the landscape, it's going to ricochet off of it like it is a laser, and this is some sort of mirror. So perfectly bouncing off of that geometry, like ricocheting exactly the way that that would, based on essentially the normal of that object. Okay, cool. So that's creating a single ricochet. I'll reset its position, pull it. Actually, yeah, we'll just reset that. So now I want a whole bunch of lasers shooting out. So I'll create a brand new sphere, set the sphere to a icosahedron, I think icosahedron, and shrink that down a bit. So you can see I've got this sphere. And then I'll make a matrix object. So I'll say, hey, I'd like a matrix. Matrix, I'll just make a child of it because why not? And I'll say the matrix should be based off an object. What object? Well, the sphere. I don't want to clone 20 of these onto the surface. I would like to create exactly one per polygon center. So now you can see I've got all of these different ones being cloned onto the surface. I don't want quite that many. So let's pull back on that a bit. So we'll start out light, and we can increase it if need be. So now we've got the sphere, we've got this matrix. Now I could hit T for scale and scale this down infinitely small. And I don't think it's going to create problems, but we are in object mode. So when I scale, I am scaling the model, which is, typically you don't want to do that. So if I could scale that way down, and you see it actually gets smaller, it's fine. So now in the Ricochet, I'm going to say that before it was just shooting a laser forward on Z. That's all it was doing. But now I'm going to say, actually, don't aim a laser on Z. Be based on the matrix. And now I reference any matrix I want. So I'll drag in this matrix. And the instant I do, you can see that we've got a whole bunch of lasers shooting out from it. Every single matrix objects become, every single matrix clone, every point of the matrix is now a source point for a new laser. And you see a whole bunch of different lasers shooting out and bouncing off of this terrain. So if I grab the sphere and I start moving it, you can see that all of those are going to update and be bouncing off the ground accurately. So that's cool. Now, because we're not inside one object, we're kind of bouncing on the outside of the object. It's going to, for the most part, bounce off of it and go into space. And I want to be able to visualize this a little bit better, so I'm going to put this into a sweep. So the Ricochet fed into a sweep, which will get a N side. T for scale, shrink, shrink, shrink. Okay, now we can see those a bit better. And automatic, and we'll make them bright yellow. So now we can very clearly see where those lasers are going. Let's make them red. Why not? Need some red lasers. Okay, nice. A couple of segments to make those nice and round. Okay, so we got a bunch of lasers and they're bouncing off of this ground, working well, pretty straightforward, and it's seeing all the geometry no matter where we want it to bounce, it's going to work. But there's additional settings we can do inside of Ricochet. In this case, I could say that there's actually, depends on what you want it to do. There's two different modes that do something interesting here. One thing we could do is say, I want to change it not from a particular length. In fact, let me show you. I can pull this way back and you see that this length is really short and we can start increasing it. So you can see that the lasers all shoot out. And then if I let this keep on growing, as those lasers reach a increased length, they're going to bounce off the ground and keep on shooting off, into infinity as long as we make this. Alternatively, I could say I want this to be based on a certain number of bounces. What is the count of bounces? So now if I turn on count, I'm going to say that I only want a bounce of 1. And now you'll see what happens is a laser only exists at all if it has collided with something. So each of these lasers hit the ground, which means, oh, I suddenly exist. Now, it's not going to generate the next bounce, essentially, because there's nothing for that bounce to collide with. It would be flying off into space. But you can see that now we have just these lasers. And what's cool about that is if we take the original object and move it, then, let's see. Oh, that's interesting. The matrix, maybe the matrix being a child is confusing that. But you can see as I move this, that only where those I'm going to try rotating. You see how some lasers are going to turn on and some are going to turn off depending on what happens to be colliding with geometry in any given moment. So you can see that we've got all these different lasers, each hitting the surface and immediately stopping. But if it misses, if it flies off into the sky, then it just doesn't exist at all. So that's one thing you could do. Alternatively, in the Ricochet, I could make it based on a length. So it's like, we can make that really long laser. And then under the modifier tab, we can set a terminator object. So I could say, if you hit any of the geometry because of the connect, then instantly die. Like that's as far as you can go. The difference between those two modes is now you'll see that even the lasers that didn't hit anything, those are still existing. Those are still flying off into space. But the ones that did collide, that is now hitting the ground and perfectly stopping there. It's not going through the ground. It's not bouncing away. So now we do have lasers that when they hit the ground will stop. And based on those actually stopping, we could do anything we want with the rig. So I'll do the simplified version here because I want to do it quickly. But you could clone. Now, let's make a cloner. And inside of that cloner, I would like to feed a sphere. So we'll put the sphere in there and T for scale. I'll fix that in a second. What do I want to do? Well, I want to clone onto an object. What's the object? The object will be Ricochet. So now we're cloning a whole bunch of these onto Ricochet. Currently, it's making 10 per line. But I'm going to change that to be exactly 1 per line. And I don't want it to loop. And I want to offset it. So it's not starting at 0. It's starting at 100%. So now what's happened is I've cloned a sphere onto the tip of every laser. But what that means is there's now a sphere exactly where the laser is colliding with the terrain. Now there's a whole bunch of these that, there will technically be a tiny little sphere like way out in space wherever that hits. And honestly, the length here doesn't even really matter because there's not going to be any additional calculation. So I could, add an extra 0 in there, make that go 10 times further. The sphere is super tiny. We'll never see it. And it's not going to take any longer to calculate because there's nothing to collide with. Anyway, yeah, so now there's a little sphere on the end, so you could, this could be a light, and that light could be generating a glow where it was colliding, or this could be a little bit of fog, whatever you want. Change the material to automatic, set that also to be red. Oh, sorry, I meant to do that on the cloner. Yeah, so those are all red. We got little red spheres on the end of each of those. We can go back to the original sphere, which has got the matrix, which is what the Ricochet is referencing. And I can go back to rotate, and you see I can spin. And each of these spheres is going to be stuck, like traveling along the ground, because that is just where that laser happens to be hitting. So there's actually a lot of crazy possibilities for this combining with other rigs. Like, this is a kind of a straightforward version, but you could... I know I had experimented with like a concept where these were spinning around and moving, and these would kind of be like these little legs. You can imagine almost like a Venom thing where that might be moving along. But yeah, that layers up really nicely. I mean, we could go back to the original sphere and increase the segment count. So yeah, now you see there's like a whole bunch more lasers, and more lasers mean more collisions. More collisions mean more spheres being applied on the end. We could increase that some more, and you can see we can just keep on increasing it, so we get tons of lasers and we get all these collisions. But keep in mind, like, I'm successfully placing all these spheres, but these lasers are like really visually in the way. But those don't even have to get actualized. Like, we could turn off the sweep, and I could even visually hide the Ricochet. And what do we have now? I have a whole bunch of spheres placed where, at a spot where this sphere, like this sphere right here, that can see these spots, and it casts a laser down. But this is just where those happen to end up. And like those matrices could be different colors. I don't know if you can extract a color from a spline, but yeah, the spline could get different colors. So yeah, so many different possibilities for scanning and layering things on, showing the Ricochet, not showing the Ricochet, bouncing it, letting the lasers fly off into space or not fly into space. The combinations get really pretty crazy pretty quickly. And then I can click back on my camera, double click on that Ricochet, even with all that moving around I did, and now boop, I'm instantly back to that exact spot. I know we're in Redshift right now, but I'll shift that to standard render just so I can make a file or an environment just to show you. It's really, when you build these types of environments, like, it's really nice to just add on, like, it doesn't even need to be too much, but like just adding on a bit of atmospheric fog in here. Maybe give it a bit of gray, bit of hazy blue. Things get more gray as they go into the distance. And yeah, I guess we need the right number here, but 1, 2, 3, 4, 5. They'll fade out too much, but yeah, anyway, a little atmospheric fog goes a long way for this type of environment. So yeah, that is a really fun use of Ricochet, and I don't think I ever really got to talk through that one too much. Ricochet lasers. Yeah, I didn't get to talk too much about that one even when we launched it. So thanks for that question. I like being able to show off a little bit of Ricochet sometimes. Any questions along those lines, or we can move on to something completely unrelated? Is Ricochet compatible with 26? Yes. It works with definitely R20. I think, yeah, R20, 21, 22, 23, 24. 25 and 26, all of our plugins are compatible with. I think Ricochet actually goes back to R18, but all the others are R20. Because R20 is when fields came out, and our tools use fields, so that's why we decided to do that hard cutoff there. Candy Trashfire is asking about putting rope dynamics on the splines, and 100% you totally can. While we're here, just to show you, and this type of thing is really fun. I'm going to change the Ricochet to be back to being the count, so only lines that are actually colliding with something are showing up. That one's actually hitting the mountain way up there, which is kind of funny. I actually don't want that one hitting the mountain, so because I want to kind of keep everything a little bit closer. So I'm going to rotate until, yeah, so now these are all kind of hanging out nearby. Now, of course, the upcoming plugin utility splines isn't quite out yet, but we can subdivide these in kind of a generic way. Let me drop this to count of 4 so you can see nice simple lines. If I change Ricochet's spline, we can enable the intermediate points, and I could say I want this to be linear subdivided, and I can see every 5 units, it creates a subdivision. So like I said, this will be better in utility splines, but for now, we've got a couple of subdivisions in there. So now that there are a couple of subdivisions, we should be able to, well, we would have to, unfortunately, have to make it editable because you can't, well, is there an easy way? I can't lock to a collider. What I wanted to do is like lock the ends down really easily. There's not an easy way of locking the ends down unless we make it editable. If you make it editable, then it's easy. Yeah, if I add a new simulation rope tag on there and don't even change anything, no, these aren't, the ground isn't the collider, and I will be careful and just do one. Oh yeah, I did it carefully because I know that I should be CPU. Okay, so if I hit play, you'll see all those just fall away. I don't want to, this is a lot of geometry to collide with. I don't know how quick it'll be, so I'm going to delete these mountains and zoom back in again. And where did, oh, and turn that back on again. So that, okay, so those lasers are now shooting. Can we make that a collider? I'm just curious, making that collider, like what ends up happening. So again, I want to be careful because there's a lot of geometry here. So I'll go a couple frames. Oh, it seems pretty quick. Hit play, and now we should see these ropes like collapse on the train pretty well. And then we can hide this original sphere. So now you can see we've just got all of these. And what I'd love to do is make this original sphere like really, really tiny. So I'm going to set it to like 0.1. Shouldn't really change the laser. It just means they're all really close together. And keep in mind, turning out the sweep, we've got all these different beams. And those are not perfectly on top of each other, but they're very close. They're like, they're within 0.1 of each other. So if I add on a simulation connector tag and we make it, I'm going to make I don't know how many, I'll say 20, or whatever, 22 connections and say, go ahead and create those. I think we know for a fact that all of those are within a radius of 1 of each other. So hopefully those all just got connected with each other. So if I hit play, then, yep, you see all of those are seemingly staying, well, yes and no. It kind of felt like they were sticking together all right, but then kind of not. Oh, they weren't at all because I didn't turn on same object. So it was just visually gravity looked like they were going down. So anyway, I'll recreate those. Hopefully they're stuck together now. There we go. Now those look stuck together. So now look, all those different things are stuck together, and we got all these different ropes all going. Keep in mind that these spheres these spheres are still moving because those are just being cloned onto the tip, but it almost makes them feel like those were dynamic, getting pulled around. And what's cool is like this is still a very parametric setup. So if I go back to the original sphere and I increase this, you can see that there's now a whole bunch more. Where's that one going? Oh, the environment. Hidden mountain. Oops. Turn off all. Turn that on. Turn back on the connect. Okay. So anyway, now I've got a whole bunch more of these just by changing the count of the matrix. But all I should have to do is say, okay, let's make sure the max connections is pretty high. Clear the old one. Create a new one. And now hopefully all those got connected together again. And I wouldn't be surprised if it starts running a little bit slower. Nope, still incredibly fast. And you can see that those are all still connected. So yeah, pretty cool. I mean, and nothing's been made editable. Ricochet is still live, and that's still working given this circumstance. So that's pretty cool. Like I said, right now the connect, or this auto connect isn't, we can't stop it from, if I wanted those edge ones to stay where they are, it's not hard, but we have to make it editable. So if I make this editable, so the Ricochet has now been made editable, I can select all the points. Let me turn off the sweep so you can see it. You see that if I select all, there's actually only the first and last point, which is really all I want. All the rest of them are being generated via the intermediate points, via the subdivide. So I think if I say that these outer points, all of them, which are alive right now, I'm going to say fix those so they're stuck. So these points can't move and those points can't move, but all the in-between ones I think can. And I guess given the circumstance, we don't need to worry about that connection. Anyway, in theory, just by doing that, yeah, you see those are now stuck where they were on the outside. So now we get this really cool, like, this really nice quick layout of all of these being connected and stuck in those original positions. And, keeping in mind, we could release all of those and point mode, spline. I could deselect all these ones in the center. So I'll say not visible only and deselect that. And now only these outer ones are selected. So now if I say clear it all, set those, and now make sure that these connections are looking at the same object, create. These should all be interconnected. These are stuck where they are. Turn the sweep back on again. Hit play. And now, yeah, now we get this nice little tangle of wires here in the center, and they're stuck on the outer part. So yeah, a lot of really fun things you can do with ropes right away. Combining the new rope with Ricochet and combining the new rope with Mesh to Spline, both plugins from Rocket Lasso, like there are so many like really cool combinations that you can do. So yeah, super digging that. Yeah, thanks for the follow-up. Very fun. I'll save that with Ricochet lasers rope. Checking the chat if there's any follow-up. Nope, looks like we are done on this particular one. P Mike. From Pete, can you show how to use the selection nodes to select polygons? I couldn't figure out what to connect to what when I was trying to create selection sets for material tags. How to use selection nodes to select polygons. We went over that a little bit last week, but, or was it last week? It might have been last week. But we can do a simple version of it now. Trying to think of a more interesting shape. I'd kind of like to pull the duck up because the duck is a slightly more interesting shape. I should be able to find the duck easily. Duck, 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 rubber ducky. Like I said, the rubber duck is not ready for distribution yet. So we'll throw it into a, where's the duck? Ah, okay, so we got the duck. He's not ready for distribution yet, so I will throw him into a remesh. So it's going to kind of mess up his his topography a bit. But we will put the adaptiveness down to 0. Okay, so this is going to be our mesh to do some selections. Most of that stuff doesn't matter. So we need to move into nodes, clear out my current search, and look at selection. And I like seeing this as a list shrunk down all the way so we can actually read everything. So we've talked about this a little bit, and it makes perfect sense, but it's not artistically intuitive that if nothing is selected, Cinema acts as if nothing is selected. And if we're talking about the world of nodes, you have to assume that nothing is selected. So the very first thing that I might want to do is select everything. So if I'm going to drag this select node under the duck, and it's currently saying polygons, active selection, and then what do we want to select? Well, we need to show this. Oh, there's also maybe a little bug here, which there's a pain in the butt bug that makes it a little difficult to visualize this. Let me see how well we can do. I'm going to put the standard mode. And now if I create a material, we get a standard material. And said standard material, I want it to be very bright so we can obviously see it. Okay, so I would like to limit the selection of that. So in order to do that, let's see if we can store a selection, okay? What do I want to store it as? Well, I think that's the name. So let's just say node selections. I'm going to select it, copy it, and be sure that I can paste it properly in there. So you'll see right now that in theory, this is storing the selection, and this tag is saying, okay, I'm going to show you what was selected. And you'll see nothing was selected, which is correct. This select was not selecting anything. Now I could try saying select all, and now as soon as I typed in all, we can suddenly see everything was selected. Now the select node, it's a select geometry selection node, which is now a capsule, can do a lot more than that. We can type in 0 through 25. And now the first 25 polygons have gotten selected. Because I did the remesh, everything's kind of random, so these are not very linear. Like if this was a sphere, these would probably all be in sequence, but now they're randomly selected. But I could say 55 through 99. We could say 55 through 99 and 200 through 300. And, oh, no, maybe we can't say and. Maybe it's just commas? Yes, I think a comma. Yeah, you can see by adding a comma in, I'm able to add additional selections. We can also say like comma 1, comma 500. And we can keep on, you can just keep on adding things manually there. We can type in the word even. And now every even polygon, like I said, if this was a cube or a sphere, then these would all be in order, but it's been kind of randomized. But essentially every other polygon has been selected. We could say odd. So yeah, that all works really well. And we can do the selection. Anything that comes before the store selection is going to be what it represents. So we could just delete out that select, and now it represents nothing. And we could grab a random selection and drag that in, and now it's randomly selecting 50% of the polygons. We could decrease that. I could keep on changing the random seed, and now we get like a disco duck going, and we're able to randomly select polygons here, and that's automatically showing it. So if you think of it this way, it's pretty straightforward, but visually, because you're not getting a good indicator, you just don't know what you're selecting unless you kind of like very mechanically have it in your head. And then even from there, it's like, okay, now we've got these random selections. And I could say, okay, based on that selection, I would like to grow the selection by 1 step. So it's growing each of these out 1, which is going to be a lot. You see immediately almost everything is turned pink, but that's because we grew the selection. And if we shrink the selection from here, after that, it's going to look very different because now only the ones that were deselected could shrink from there. And we could say, hey, shrink multiple times. And if we go back to the original random selection, all that stuff will filter through. So every time I click, we're getting a completely different layout based on those random selections. Deleting all of those. We also have things like the noise selection, which is pretty cool. Let's see. That one didn't immediately pop up for us. Let's try changing. Oh, it looks like it's a really large noise. So let me start shrinking it. There we go. So yeah, now it's a noise selection based on a Perlin noise. We can do different random seeds, and you can see that yeah, we can randomly select based on the noise. And then things can combine, which is also cool. We can in this case, here, let's rename this tag to be, no, I want to keep that one. I'm going to make another one though. And this first one, I'm going to rename to be noise. So now there's a noise tag. And then, so this is now saying, okay, randomly select a bunch of things and store that as, did I do that wrong? I did. I'm going to say that should be storing as noise. So now that is stored as noise. How did I do it wrong? Well, I did it wrong no matter what. Okay, so now that's storing the noise. So this other one is still like, well, I'm still the same thing, so it's going to override. But we could start over again. So in this case, let's make a select after that one. And this time I'll say, hey, I want you to select every even polygon. And then that is eventually getting stored here via this store selection as node selection. But now we have... I'm going to make another duplicate of this, and now let's call this one even. I need to modify that a bit. I can't think of something better. So I'm going to put 2 V's because I don't want to use the word even because even would be, let's just say every other. That's better. Okay, every other polygon. I didn't want to use the same name because now we are successfully storing some random inside of here. We're successfully storing all of the even inside of this one. And then here's our final one, and that's what's actually going to get applied. But now we can do additional cool things in here. Like I could say I want noise. Actually, you have to put these in quotes. Noise. And I think we can say plus every other, which are just 2 different tags that I made. And now when I let go, you actually see the combination of those. But I could say noise minus every other. So now we're only seeing where those 2 things both happen to be. And we could also, I think, say comma 1 through 100. And now those are also added to it, or we could subtract from there. So you can see how we can make a bunch of different selections and then via text, combine them all in very complex ways and get like, you know, some really nice layouts. Storing that is what's stored into here, and that all just filters through. So yeah, hopefully that makes sense to everybody. Yi Hakim, I mentioned you cannot post a link on YouTube. You have to go on the Twitch. There should be a link in the description, I think. If not, just go search Rocket Lasso Twitch, and you should be able to find that and join in the chat over there. But yeah, making these selections. As long as you know the regular cinema things, we can now do it procedurally, which is pretty cool. Back onto Twitch. Let's see. Lonely Penguin. Is there some way to, let's see, this is going to be tricky. Is there some way to link sound amplitude to a displacer? Not the loudness, but the exact amplitude line. I mean, that's a wonderfully specific. Okay. You sent over a, these are some not appealing ads. I'm going to be careful about how I pull this over. Let me refresh. There's a bunch of like weight loss ads appearing. They're kind of gross. Anyway, you can see here what they're asking about, which would be, could we translate this shape essentially into like a loft or something? It's a good question. I've never attempted something. I've never tried that idea specifically. Is that even a thing? Because how much, not many things can pull in. I'll make a okay, I'm going to start out with a matrix. We'll set the matrix to linear. I'll say only 10 in between each one. And we'll make a whole bunch of them. Okay, so there's a linear line of a matrix. Into the matrix will be fed. I'm going to do a plane, actually. So we'll say plane effector, offsetting it on Z by 500. So these all get offset by 500. Pretty exaggerated. That's fine. Now we'll limit that via fields, and one of the fields should be the sound field. So we just kind of break apart the different elements. Now that's going to require me to load in a sound. And I don't know if I've got anything handy. I think cinema's less picky than it used to be about audio files. Let me think. I mean, I guess it just needs anything. I'm going to just search my hard drive for .wav. I gotta have something. So we'll give this. Unfortunately, Windows searching is significantly worse than Mac searching. Mac would like instantly find them with all the really great indexing it does. Oh, indexing. It's not. Oh, suddenly a bunch of stuff popped in, but ooh, pinball machines. Those might that might work. Empty button release. Try and find one of the sound effects I know is a little bit longer. That might not be too long, but let me open file location. Oh, there's a whole bunch of them, so that's fine. Okay, here is the location for the pinball machine I designed in Cinema. And let's just try and grab one of these. I mean, that should be fine. So let's see, does that work? Yeah, okay, we suddenly see the waveform come through. Now, what's going on here? Am I crazy? Why is it not letting me scale my window? Like, I can pull that one, but look, it's not letting me. What? Why is it not letting me grab this viewport? I wanted to make that a little bit longer. That's a little annoying. All right, I'll pop it out then. So the basic idea is this is going to trigger to varying degrees depending on the amplitude that it sees and a bunch of different things. So can we stretch this out to see all of it? But you'll see that it's just applying uniformly to each of them. But this is sampling the peak. Step, average, decay wouldn't do anything. Color doesn't mean anything. This is just merely finding the peak at any given moment. Which all makes sense, but that's not what we want. You can do multiple probes, but the different probes are just going to be sampling the same box. So it's like, oh, we're sampling this spot, and I could add another probe so we get a second box. That's kind of, and the second box we can, oh wait, that's interesting. It's doing every other. That's strange. Every other. I mean, does that mean it breaks down? Like if we kept on adding more probes, could we? Like, would that eventually break down? Let me delete that one. Add a probe. Add a probe. I don't know. Oh, it's selecting things a little oddly. It goes to if we made, I don't use this tool very often. If we kept on adding probes and we add the exact same number of probes as we have matrix objects, would it be lining up? So it would be a bit of a pain, but you'd only have to do it once. So I'm just going to manually do a couple more, kind of an experiment. The more you make here and the thinner you make them, the more accurate it would be. I'm just using the default because it's going to be quicker. One more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I made 14 of them. So if I set my matrix to have exactly 14 clones, yeah, there's only 14 of them. Now, if I give them a little more space in between and hit play, then now each of those is representing that very specific spot. And you saw how I did it really quickly. And this is very manual. It says distribution, iterate, distribute, blend. Blend might make it so that we could put more matrices in. Let's see, I'm going to make more. This isn't actually increasing the resolution, but it does mean we can make more dots. Yeah, because it's blending between them. So that's going to look more detailed. It's not necessarily that much more detailed, but it's going to look better. Anyway, you now see that that is properly kind of making a waveform. And I did this through a matrix, but even the matrix will still work if we create a tracer object. And now we're feeding in the matrix. I'm going to say, I don't want trace paths. I want to connect all objects. That seemed to have worked. So now you see I have a spline. If I hit play, then now we get a spline going bzz, 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 bzz. And if I feed that through, as you did in the visual reference, into a lathe, then now we get the sound translating through. I think it's still true. The more of these you make, you probably want to make these like way thinner. And then you could make way more of them sampling all the different spots. But it's working. And we're using this so we have, we can also use things like the decay, which always make it look way better. So just a little bit of decay makes it so it's like calmed way down. And even if we don't do a decay, we're still in the world of effectors. So doing something like a delay or a decay, like a little delay, and I do mean a little, like, a little delays, calmed it way down so it makes, like, we can see it way better. And then it's actually literally the same thing as the peak, but we can add a decay, and that means they're going to be fading out slowly. So you can see how it's going to fade slowly. If we make it fade relatively quickly, then it's going to calm everything down, and it just becomes a lot more visual. So there you go. Yeah, it's cool. I hadn't ever specifically done that. Honestly, I didn't think that was going to work. I thought we were going to have to try and do a thing with espresso, and I wasn't even sure if we could do that, but totally worked. I like it. Waveform to spline. Neat. How'd you go about creating wrinkles? I don't like... We've gotten wrinkle questions before, and it doesn't go too well. I feel like... I know ZBrush is inside the Maxon family now, and you could do wrinkles amazingly fast inside of ZBrush. I don't know ZBrush at all. I don't have ZBrush installed, and I haven't played with it in like 8 years. Yeah, I see what you got here. So those, oh, that looks cool. Well, I mean, this is doing several different things. So it's a video from Blender. It's doing several different things where maybe the forehead, yeah, the forehead is wrinkling, the eyes are wrinkling. Presumably this is a very specific plugin and or add-on that was added to Blender that is doing a very specific job of it. And there's going to be a whole tutorial using that very specific tool. Presuming that it is a specific tool built to do that type of thing. I feel like we can emulate some of those effects, but we'd have to be building very specific rigs for each one of those circumstances. Where the simplest version, which we can just, it was such a simple thing, I think we can directly emulate. If we take this shape and we need a whole bunch of subdivisions on it, we could potentially just put the subdivisions where we wanted them to be, but you know, I'm gonna just put them everywhere because it's simple enough. Create a bend deformer and fit to parent. Don't need to be that tall. Keep length, bend like that. So you can see how that is bending. So if we make the cylinder editable, we can add a vertex map. No, we're going to add a rigging tension tag, and it needs a fold map. So I'm going to say make map, and then we're going to fix the tension where it is right now. So we select the vertex map. It's saying like, okay, that's 0 tension. And we are, by definition, doing the fold map. Stretch map would be pulling apart. A fold map is it pinching together. So that, having said that, if I now activate this bend, you can now see that those suddenly are illuminated. You can see that these are lit up. So let's keyframe that so we can actually visualize it. So frame 20. Well, the bend will be animated to 0. Oop, 0, please. Okay, so, and we'll just duplicate that a few times. No, don't duplicate it. Oh dear. Deselect. Oh man. Select that one keyframe, duplicate that, and then shorten our timeline down. That's better. Okay, anyway, now you can see that when that bends, that is now illuminating. The tension tag has an amount, so I need to see that, but I need to pop that out. So there, that should show us both. So here's our amount. Do I need to increase this? Yeah. Okay, so what we want to do is essentially find the spot where this gets all the way up to yellow and doesn't go too much beyond it. Essentially, we want to try and get that full range of motion. So we now have a tension tag, which is feeding into a vertex map saying like, hey, this area has changed because it bent. And all it cares about here is bending. Now, assuming that this is the type of motion that we are going to get, we could, how do I want to do this? Let's make a plane. Does that make sense? Maybe the order of operation here could be weird. I'm worried because the plane, I want the plane to come before it, but the bend has to come after. So I'm not sure how this will go. So anyway, this is going to be a deformer. So I'm going to say, yes, deform the points. Quite strangely, the plane. I guess it isn't Y. There we go. That's what I wanted. So I'm going to have those push outward. So this plane is now doing that. You can see how it's pushing out. Then I will limit what it's going to do. And in this instance, I will do it via a shader field. The shader field will be referencing a noise. The noise will be infinite on everything but Y. So essentially, you see I was able to quickly kind of make some random wrinkle shapes. Depending on our Y height, we can pinch these down to be way smaller. If we subdivide more, we can make them sharper, obviously. And we could increase the contrast here. You guys see them get real blatant. So anyway, there's a random way of getting some, essentially, wrinkles. So this is now pushing out everywhere. But if I say, hey, shader field, you can only get applied where you are multiplied by this. You see that there's nothing anywhere. But in theory, if I play and let that bend, yeah, there we go. Well, okay, so while we're seeing that problem I was kind of anticipating, you see that the wrinkles are appearing. They're based on a material, so that it seems like it's static, but you see how we're getting some twitches in there? And that's because the plane is coming after the bend. We might be able to just no, because then it passes through. I could make the noise potentially 2D. Okay, there we go. That's finally a combination that's stable. So I'll shrink those down. Yeah. So now you can see that based on a tension tag, we say, okay, here's a predefined wrinkle. And as it bends, the vertex map gets brighter. The vertex map acts as a mask for where we've actually we've already put wrinkles there. And this plane is deforming. And, you know, making those wrinkles appear. As I said, this is a one-off rig. It's not automatically doing it. But you can imagine applying this concept using that tension tag kind of everywhere. And you can do the opposite, where a stretch will make certain things happen in a certain spot. All you have to do is predetermine. I mean, it's actually really simple to use, where you know, where does it stretch? Where does it fold? What is the relative amount? And each of them individually drive a vertex map. So you can get this pattern. Trying to think if there's anything else I would really do. Type Ogre is asking to turn this into a hand. I don't know about that. Because you need a ton of subdivisions, and I wouldn't want to make something I rigged. I wouldn't want to make something I rigged highly subdivided, because if you're rigging something, you want there to be as few polygons as possible. You could do it via like texture tags on there, and it could apply as a displacement after the fact. But then you'd still have your low poly version, so maybe the wrinkles wouldn't be going exactly where you want them to be. And even on fingers, like if I look at my finger as it bends, like it's not the same type of wrinkle. It's not like it's not like a whole bunch of tiny little wrinkles pinching as it goes. It is, I don't know, you're looking at it, it's almost more like a smile. Like there's a single fold over. And when it comes to that single fold over, you start getting into needing to do like a proper, like skin, like bone, muscle, and skin simulation, which is, you know, it is a thing. And in a lot of ways, it's more doable now in cinema than it ever was before. But there's still lots of dangers with it as well. So I will save this one. I'll save it in a spot where it actually shows the wrinkle. Tension tag wrinkle. In this particular setup, I'm going to keep the bend, but we don't need the vertex map or the tension. So now all we've got is this, okay? If we make a cylinder, T for scale, make it tall enough, we don't need that many subdivisions, which might mean it needs to be a little more radius. A couple extra subdivisions. So I'm trying not to go too crazy on the subdivisions. But if I make this bend object a simulation collider, and I make this object a simulation cloth, this is now a layer of cloth over this object. I'm gonna make the object underneath very dark so that we can see it sneak through if it does. Change this to CPU, hit play, and let's see what happens. Okay, well, you can see immediately that this is successfully bending over. Like, it, you know, like the skin, if you imagine the thing underneath like muscle, then the skin is properly bending over. So let's hide, you know, that. And now you'll see as this bends over that depending on the way things are allowed to bend, and we gotta be careful about like intersections. So we could, you know, do more collision passes because it's so simple. You can see right there, there's actually that pop because essentially it's pinching over so much that it wants to move. So depending on what the settings are, I don't know. If we make it more bendy, yeah, okay, yeah, look at that. So now by making this more bendy, we're actually getting these scrunching in. We're getting, in a way, natural wrinkles. Like based on the simulation, it's like, well, you know, the material on the outside is stretching and the material on the inside is scrunching in, and suddenly we're getting like some pretty nice looking wrinkles. So like that just sort of works automatically. So in a way, if you had a hand animation and you put a skin over it, you might get nice looking bends, nice looking wrinkles. The problem goes to like this bend can only bend so far over until it passes through itself, and then suddenly the cloth will be forced into the mesh, and then that would be like no good. But yeah, these wrinkles working shockingly well because it's running, well, I guess we are in the not quite maxed out frame rate, but you know, we could increase our subdivisions here, and you know, that should give us in theory even better looking wrinkles as they go. And then I'd probably want to hide entirely the original mesh, but then this could be fed into a subdivision surface, which is going to round it out, and you know, you see that's just going to make that cleaner. Scrunch. So yeah, nice looking wrinkles without much work. Like it's already the bend and just throwing a cloth tag on there, and suddenly we get, you know, pretty nice looking wrinkles. It's even returning back to its original shape pretty well. Depending on the settings you put in here, like something more bendy could, you know, I'm not sure, like let's, you know, keep on increasing it. So now this bend is very forgiving, or it's going to bend very quickly. It seems like more stable wrinkles. If we do 0 bendy, it's not going to want to bend too much. It's going to be very snap. You see it's kind of snapping into position, so it seems like a lot of bend is a good thing in this particular instance. A lot of friction could help or hurt. Let me try cranking that up. Yeah, you see it pinches a little bit harder, where if there's almost no friction, it should be able to slide over itself very cleanly. Yeah, so pinches can happen more. And you see we're actually getting one very nice pinch there. Like, look at how that one like fully folds over itself. So yeah, once you get to a certain place, the only thing you can do is essentially do it like real life. And in this case, it would be, you know, bones, muscle over the bones, skin over the muscle, and everything just goes where it would go, because that's what's happening on your finger. Anything, you know, when you look at the way your finger would bend, to do anything beyond this would be incredibly complex rigs where it's like you have to paint in the geometry in a particular position and then use a morph tag driven via a joint bent at a certain degree to like trigger the morph to be happening. And then it goes to, or if you had an advanced enough system and a good enough computer, it's like, oh, well, let's just throw some skin over it and then let it go. Let's see. But yeah, I mean, it's fun that we can layer these things up. So since we'll do B, and we'll just call this skin over mesh wrinkle. But yeah, it looks like Kim has got a updated link that hopefully will play. Mute the tab, hold it over. You seem to have found the example on Instagram. It's from Unit 20. This is now saying Unit 20 from the Bartlett School of Architecture. So that kind of makes a little bit of sense. So, okay, so it does seem like it's this suit specifically. Let me see if I can get this a little bit bigger. Easy enough. I'm having trouble seeing what's going on. I mean, it looks cool, but unfortunately, it's not. Yeah, it's not at such a resolution. Yeah, it's saying stuff like scale response, normals removed, scale response, inverted ramp. It's saying scales. To me, I don't see scales right now. I wish I could see this at like double the resolution. Because while it looks cool, it's also kind of like visual, as far as mechanically knowing what's going on, I feel like it's a lot of visual nonsense. Like here, it starts looking a little more consistent, but as soon as they're moving, or even here, it's like, I don't know what's happened here. Like, is that a series of spheres? Is a series of striped lines? I can't see it at this resolution. And I gotta say, nothing is immediately jumping to mind. As far as what I would do to execute on it. The only thing it's vaguely making me think of, which is not what I think is going on, but it's when we do that doubling up of a deformer to get a inflation effect. So like if we subdivide something decently, and let's make a plane effector, which we will use as a deformer, deform the points, not on Y, but on Z. We'll drive it via a shader field. And inside the shader field, we'll feed it a noise. The noise will become two-dimensional, so it's stuck on the surface. Pick whatever size we want. We could even grab something like a Voronoi 2? No, not 2, 1. Yeah, so Voronoi 1, and then if we start clamping out, yeah, something like that. And we scale up the global scale. Oh, I guess I want to do the opposite. So we invert that and do this. There we go. So this is going to give us a bunch of little spheres, sphere-looking things. They're all identical, unfortunately. It'd be kind of cool if there was one that was not identical, which I don't think. I mean, these would be a little more random. But let's leave it as spheres. Anyway, you can see what ends up happening is if you take essentially the spherical fall off and you translate it directly onto this mesh the way that it is, that it's very, what's the right way to say? Like all it did was push straight up, like visually not that interesting. But if, I can pull this shader field out, but if we make a second plane deformer, then now it's pushing out, and then the second one is applying to the exact same thing again, and it's pushing it out. So, especially if we subdivide this more, you can see we get this really nice secondary inflation effect. Instead of this pushing up a pillar, we're actually inflating, which is a similar thing to what we did with the popcorn last week. Let's pull back on this. And you see that, like, depending on the way you combine them, that you know, if we push it a little bit, that doesn't really inflate too much. If you push it a lot, it's going to inflate a bunch. And then there's different, you can even do different ratios. Like I pull this initial one in more and then have the secondary one go further out. And even that feels different. Let's see. If I push this out, that's going to inflate even more. So there's a lot of possibilities, and these combine in really complex ways. And then keep in mind, you can even do a third one. And the third one is really like kind of like bulging that thing out. Unfortunately, you do start losing resolution on your geometry. Like these are very small, but because we're inflating something so large that they don't appear everywhere. But because these are all still based on that same shader field, if we apply a bit of animation speed on here, then these should... Oh, that's interesting. Well, let me give that a reasonable speed and tell all of these to field... frame refresh. Okay, so now they can actually update. And probably subdivide the whole thing. So anyway, you can see now we've got a whole bunch of like inflatey balloons that are like able to move around and kind of be random. So yeah, the layering up of that type of effect, like I said, like this is not very inspired by what we saw because I can't tell what's going on in what we were looking at from the relatively low Instagram resolution. But yeah, this is the only thing that it sort of made me think of. And then you could, you know, imagine if we turn off these deformers and we make a generic standard material. Standard material, please. And apply that to the plane. And in the material, we feed a simple, like, striped shader. Tiles, lines. Haven't used this in a while. So if we make different lines. So yeah, we got these lines, and now you deform those. You're going to get these really interesting kind of inflating stripes. These materials should be stuck on there because it is based on the UV. I guess they're just getting really stretched out. Yeah, but you see how the stripes like travel over the surface? If those were a little bit higher contrast. I don't know if there's a way of making those super high contrast. That's higher, very Beetlejuicy. But yeah, so those are kind of individually stretching out. But again, I'm not thinking that that's really the effect that you're going for. Achieve something similar using an explosive advection system in Houdini to rotate a series of spheres stuck on geometry. Yeah, I mean, I feel like it's entirely possible we could do something similar, but I need to be able to see what it is doing. And then I guess I'll save this, even though it's kind of a kind of a weird little experiment. Triple inflate. Do you remember when we were trying to do the dragon scales? That was like a whole thing. We did it. Well, we recently did that thing on the duck, but I feel like we should do a simplified version. So I'll make the triangles to make it very even. And how do I want to do this? We can even do it simplified. I mean, I don't want to make it too simplified to the point where it starts not working. But if I even just put a sphere inside there, shrink, what's going on? T for scale, shrink please. Clone onto an object. Object will be the original sphere. Clone onto the polygon center of each one. Okay, clones, face outward, please. And scale to 0.2 on one of the axes. I'm not sure which one I want. 0.2. Okay, so that's kind of what I want. It might not be the right orientation. But what we see right now is we get a series of essentially scales, but they're all randomly facing whatever direction. Like none of that direction really means anything. But we could start making it mean something by feeding it. Is it a plane we want or a target? I think it might be a target. A target effector. The target effector can be told to look at the field direction. And under fields, we can now feed it something like a, is it like a linear field? Maybe. Don't clone it. Thank you. So you can see that we suddenly have an orientation here. And is that because of the linear field? I'm trying to remember. Maybe. Yeah, it does have a direction. So those are all facing this way. I haven't done this in a bit. We could make a, delete that. No, just this. Make a solid. Yeah, the solid is now giving us a direction. We pushed this really far. I feel like even like 2 seasons ago. But I'm trying to remember. So that weight, we have up vectors, we have repel. I don't know if any of those would do anything. I mean, they'll do things, but I've always gotten a little fuzzy on what those do. Field direction's the key, but and that's feeding through a field. How do we do it? I don't remember. Because we can start sneaking in additional orientations, but that's just a set orientation. Did we do it with splines before? I know we were doing it, we recently did some stuff with hair, but I wonder, it feels a little weird, but I wonder if we could do it again with hair, but in a different way. So if I add in add hair, so we get these hairs, and I say, okay, hairs, you're generating a spline, not hairs, and your hairs are not hairs, instead they are guides, so there's very few of them. So if we say, okay, target, not based on a solid, but instead along these hairs, and I'm going to say not along the curve, yes, along the curve, maybe? I don't remember, but, and the curve falls off as it goes, so let's see if we can increase the start range. No, that doesn't change anything. Offset? Maybe. Maybe. And now we grab a hair tool, tear it off, and grab the brush and start painting these to start painting the orientation of these scales. Like, it's kind of nice being able to do this with hair. We might not need as many as we have. It's a little rough. And that is going along. As we offset, it gives a full power. It does seem to have them face the direction in a very literal way. So, like, that's a good thing. And then does it just go to like all that we can really do is paint this to get like to the closest approximation of what's supposed to be going on? And well, I guess I've kind of lost a thread on what the original question was, but to finish out the thought on this, if I make these bullets rigid bodies, and I mean, honestly, we want to stick them in their current position, but I'm just going to give it like a lot of follow position and like tons of damping, 99.95 on both linear and angular. And let's just very carefully go 1 frame forward. You're going to see each of these are scooting out of the way, so they're no longer colliding, but they also have that orientation that I painted in. So, you know, that kind of thing could be cool. But they're, you know, they're colliding with each other. And they're dynamic. If we turn off the dynamics, I'll save this because that's kind of cool. It's going to take me forever to write the notes on this episode. We're doing so many different questions. Brushing hair for, I'll just say scales. Anyway, I was going to say if we got rid of the dynamics and we turn off, I don't want to turn off dynamics. Let's turn off gravity. So under forces, no gravity. If I hit play, I don't think the hair should do anything. And now if we do like a turbulence, and we make the turbulence quite stronger and way huge. to try and make them a little consistent. These will follow that pattern. I guess there's going to be kind of a pop when they move from one direction to another. But in general, those seem to be kind of working. I guess we could try shrinking them, but I was curious. Now if we do make them rigid body again and essentially do the same setup, I shouldn't have turned it off. So follow position very strongly. I guess actually it's, yeah, we want to follow position strongly, but we want to follow rotation strongly as well. Lots of energy drain. So as these drift around, these should want to move. Let's get rid of all the friction. So these should be relatively free to move. But they're not going to be that free to move because each one is kind of forcing the next one into a particular position. So the only thing we could do is shrink them all to give them more room to maneuver. Which they are. Get rid of the gravity. They are moving based on where these hairs are naturally sending them. It's just not particularly interesting. But I mean, well, the fun part is that each of these scales is kind of forcing the next one into a particular position. And especially in the initial thing, like we forced them all to be in a particular direction by painting them. So those are the parts that are cool. Now, if we made these so that they were not, see, we simultaneously need them to collide with each other, but we also need them to be able to slip past, because it does go to, yeah, if I get rid of the dynamics, and each of these things is going to be moving around doing their own thing, which might start emulating a little bit more what we are seeing in the reference. This target is snapping things very harshly. We could, of course, do some of our favorite delays. And if we put, yeah, some smoothing in here, then they're not... okay, delay comes after hair. Then now it's stopping them from snapping too harshly. And that's controlling the direction. That could also be a spring, so now they're kind of springy. Not as nice as smooth, though. Yeah. Well, yeah, now they're not colliding, so we could make them larger. So it's like, you know, we could make some things that look cool. How large can I make that? I want these to be a little bit more uniform. Where we might be able to get like some distinct patterning, because like all these are blowing in similar directions. If I turn this on, you see the hairs are all gonna, in general, blow in particular ways. Let's see, I might even be able to, dynamics, properties, fix roots, surface radius, hold roots, yes. No, hold roots 0. Yeah, now they're able to like fully travel through. I don't care about collisions. Yes, they are dynamic, but I don't care about collisions. So now they're kind of free to move every which way. I would like a decent amount of drag. Okay, not that much, but enough to drain the energy out. And yeah, there we go. Without them flopping all over the place. Now the turbulence is free because it's a large turbulence. Not totally. It's not, it could be bigger. If we have a very large turbulence, then they should all start essentially fighting to be in a similar direction. Not always, and they'll lag behind, but you can see how we're getting kind of this really nice kind of organic transition from one direction to another, and they'll all just kind of organically transition into those other shapes. So, you know, if this is something similar to what was happening in it, like, you know, that's an idea, it's something. And we are using all these like interesting direction tools. And if we start, you know, adding in more smooth, so they're a little bit slower to snap if they pass over their own axis. So those are all looking okay. And again, well, it goes to what I would love, and it just goes to, you get that inherent contradiction. But if we made these rigid bodies, then we drain out the energy, tell it to follow position rotation. Just restart. So, you know, these are so large that they're fighting, and because they're so large and they are fighting, they cannot pass through each other, and now thus they have almost no option as far as their direction. The more we shrink, the more that they can fit in their spot, and we might feel a little bit of rotation. Yeah, a little bit. And the smaller we go, the more they'll actually be able to change to a new orientation. very sluggishly, but that might be because of my very extreme damping. Huh. Was it the damping that was doing it? Maybe. The orientation's not changing too much. But anyway, you can see there's a lot of push and pull here, a lot of interesting things. And we did have a lot of luck doing the scales a while back. But even that, we're seeing that we're getting that all right here. Like where, if we go back to the original frame, that we could paint the hair up into a particular position. These lay out pretty well. And then when we allow the dynamics to take over, then all these will sort of lock in. And if we put connectors on it, they would all bend in the correct orientation, and they could only spin in certain ways. But yeah, I'm sorry. Sorry, Yihakim, that I can't see more accurately what was going on for those orientations, but that's as far as I can go. And we're almost a half hour over, so time flies when lots of questions were coming in. Dean, I'm glad that somebody appreciates the live stream notes. I put a decent amount of, it's shocking how much time it takes to put those together for like finding the time codes and the links and a little description of them all. But anyway, yep, we're already over time. Thank you so much for everybody coming and hanging out and asking questions. Any questions I didn't get to, hold on to them for next week so we can dive right into them. It's always and even when the chat starts, when the stream starts, and we, I know we don't get going for a couple minutes, like feel free to start putting them in there so we can get started right away on a question. So having them pre-set up or anything that pops up over the week that you'd like to see, make sure that you do hold on to it so that we could, so we can properly tackle it and answer it in the question. Anything else to do? Go check out that highlight clip posted if you want to see some nice advanced field stuff. Otherwise, that will wrap up another episode of Rocket Lasso Live. Thank you so much, everybody, for coming and hanging out. I'll see you next week. Otherwise, bye-bye.